Good evening. Sunday, start of a new month. We're into March. How is everyone doing? Hopefully, everyone can hear me fine. Let's say a few hellos. Hey, Malika. Hi, Philip. Hi, Frozen. Hi, he, Hearty. Sorry, I said that wrong. Um, who else is here? Mujtab. Hello. What topics are we here for? So, well, it depends what question you're asking there. Was it the last live prize winning quiz we did, or our last lesson? I guess you aren't in our lessons. I don't know if I recognize the name. Last time we did a quiz on, is it waves? I think maybe I can't remember. It's been a while. Been a while. Been a while. But today we're doing it on density and states of matter. Yeah. So you're very excited. That's good to hear. I'm happy to hear that. Good. Um, electricity last. I think it was the time before that. But hello, Devashri. Nice to see you again. Hope everyone's doing well. I'm going to start off quickly. We know the rules, but I'm going to repeat them again. To win a prize, make sure you're in the chat with me now and you are responding to me as I go through some of the content that I'm going to be covering in the quiz. Obviously, it's beneficial for you as well. The ultimate aim for this is to be a bit of revision, but a bit of fun at the same time. Yeah. So we're going to be looking at, yes, you're right. It is paper one. Yeah. So it's paper one stuff this time around. If you win, or obviously then you take part in the quiz. We've got our Kahoot quiz. And if you win that, then we want you to send us a screenshot of you in this chat on YouTube with us, and also a screenshot of you winning the prize. Yeah, so seeing you on the remember, a prize here today is a £5 Amazon gift voucher for second place, and the coveted £25 gift voucher for the person that comes in first. Yeah, so prize up for grabs. We've got 19 people in the chat so far. I'm going to start by giving out the code to everybody. Let's have a look. The code is 1794330. I'm going to put that here as well. The Kahoot code 1794330. So I want to see a few of you in there. Let me know who you are before then I make a start at looking into our content for today. Wish you could join me after joining for prayer. Unlucky, but that's fine, Mohammed. No problem. Sorry, the timing doesn't work out for you, but I know it's that time of year and with fasting and everything around the corner, so no problem at all. Thank you for joining, even to say hello. Much appreciated. But yeah, hope everything goes well, and I'll see you later. I'm sure you'll be here for many more. Glad Badger. Okay, I'll be keeping an eye out for you, Malika. That's you. You're there. 1 in 2 chance. So basically, you're in with a prize at the moment. If no one else wants to take part, there we go. Blissful Mantis. We've got another optimistic hyena, daring lion. Okay, now they're coming in. Playful Yeti. Okay, I see a few of you. So Smooth Newt, that's you, Frozen. I'll be keeping an eye out for you. Can you do it for the FRL classes members? Good luck. Yep, thanks. As Mohammed says, good luck to everyone, and we'll see you next time, Mohammed. I'm sure. I'll see you soon. Flying Jellyfish is Debashri. Okay, so I've seen a few names I remember. So we got Glad Badger as Malika, Smooth New as Frozen, and now we got Daring Lion as Muji, and we've got Flying Jellyfish as Debashri. So let's see how much I remember those. I probably will forget as we get into later, but I will definitely ask Kusu. But let's have a look and see some of our content for today. So far, we've got 11 people. I've put the code here, 1794330. But let's have a look at some content. So for those of you that haven't seen our website before, we do run this every live just to make sure people are aware. This is flashrevisionlab.com. And on here, we have for you, if you sign up, you get complete access to all of our notes. Okay, so we've broken it down topic by topic. So physics is today what we're looking at. And I mentioned we're looking at density and states of matter, which is in particle model of matter, subtopic 3. So I click in there and I can see it's broken down literally by the spec, by each point. See, so even in the spec, you'll see these points all match up as well. Trust me, guys, they're the best. So, yep, thanks, Philip. Much appreciated. Philip is one of our FRL classes members. So as I was saying, with the just free sign up, you get access to all these notes. Yeah, you click in here, you can see all of the notes covering every single spec point. How do you know I'm not lying? Well, have a look at the spec tab. Yeah, and in here, it tells you exactly what is covered in the specifications. This is an excerpt from the specification. check back on our notes. We're covering everything you need to know. Yeah. We then have access to questions. Yeah, there are exam questions for you to try. And if you want to check how you did, you can see the mark scheme and compare your answers to it. Okay. If you want full access, go to FRL Pro package. Okay. It's only slightly more. It's just a slight cost of just less than basically a cup of coffee. Yeah, you buy it, and every month you get access to everything on our website, all the questions, yeah, and all the notes, and also our new flashcards feature. So here, for example, that's my first question for everybody. This is not the quiz. This is just a quiz within the quiz. What unit is volume measured in for density calculations? Can someone tell me? Sami Mohammed called us the goats. Much appreciated. Much appreciated. Finding it pretty helpful. Deborah Shree says that's good. Someone give me tips for triple as I'm not doing so well. That's fine that you're not doing so well. There is time. That's the important thing. First of all, this is the time to really lock in. Yeah. And what you need to do is have a set of notes. We're trying to give you that. Yes, that's the first stage covered. You go through those notes, then you try some questions on those notes. Okay. Then you see how you did, and then you come back on it. If you did well, park it and come back to it later. Yeah, because the whole thing is about long-term memory. You may have learned it in your lesson at school, but then if you don't cover it again, you'll forget it. Yes, that's always the thing people don't do. They don't revisit enough. Okay. So before you get to doing exam questions, I'd make sure you understand all the topics, then do a paper. So that's where we're getting to now. We're nearing the end of the syllabus. So here you now start to go through past papers and see where you finding questions more difficult. Where is it that you're going, oh, I don't know that. Then you revisit that. You go back to your notes and you repeat the cycle again. Yeah. So I used to use the Quizlet for the flashcards, but now I use the FRL flashcards and just found the exam questions. Yeah, exactly. We're trying to give you everything you need in one place. Yeah, so this is what we want you to do, and hopefully people such as Philip are saying have found it useful. And joining our classes, our last package, FRL classes, for £22 a month, we do each science one class a week every week. So that if you take it into account, that's 3 lessons a week, 4 weeks in a month. So 3 times 4, that's 12 lessons in a month. And that is for £22. Yeah, so you're getting 12 hours of classes for £22. So one class is like less than £2. Yeah, so I think honestly, every time I say it to myself, I'm like, we're giving this away. Yeah, but we want to, because we want people to be involved. That is the aim here for us. We want to build a community to help as many people as we can. So if you're interested, check out on our website, go here to flashrevisionlab.com. And if you want to join us on FRL classes, there are tabs to do that at the top. Okay. So joining more classes, going to more info, you can see what's happening all over our platform. Cool. I've been ill since November and I'm getting chemo this month for the first time. So I've not been to school. So it's very helpful. Thank you so much. Honestly, that is great to hear. I'm glad that we can help you. I hope that your chemo goes well. Obviously not an easy thing to go through. All the best on that. But even if it's something to give you a bit of a laugh, bit of a competitive edge against some people, take your mind off of it. We're here to just do what you can. But all the best. I hope you get well soon. And look forward to you taking part in this quiz, and good luck. Good luck. You could be the winner. For a little treat for yourself if you win this prize. Cool. So I haven't seen. Oh no, I've seen a few answers. People have answered. So people have said centimeters cubed. A few people have said centimeters cubed. I would say you're slightly wrong. Centimeters cubed is a measure of volume. Okay, but the standard unit for volume would be meters cubed, not centimeters cubed. Yeah, but we'll see. You can mention either. But here we put cubic meters. That is the standard unit. Yeah, so centimeters cubed, while it is a measure of volume, cubic meters or meters cubed is the general unit. So for me, I got it right. So I'm going to put no. But if you didn't, this is why I put still learning. So it parks the flashcard to the side. So if you go through the flashcards, it will come back to you again to test whether you remembered it. Yeah. Quiz question leaked. Maybe not. Okay. But the important thing is that you're paying attention. Okay. So keep an eye on it. Cool. What does compression do to the particles? We're not covering that today. That is another subtopic. So just to give you an example, that's what it looks like. Let's get a look at this. So firstly, density. Density is about how many particles there are within a particular space. Yeah, so the more packed particles are in a space of a substance, the more dense it is. Okay. If it's less that are around, then it's less dense. Okay. This is what we compare with thickness overall. So then we have a look at the equation applying to that, which is density equals mass over volume. So mass is measured in kilograms, and volume, as we just saw in the flashcard, is measured in meters cubed or cubic meters. So mass over volume is kilograms per meter cubed. Yeah, and that's what I've put here, kilograms per cubic meter. That is the standard unit for density. Okay. And then I've run through an example here, which literally talks through using those numbers in a calculation. Yeah, you always find, you will know two of the three things there, you find the other one. Okay. Again, the equation is given in your formula sheet, but it's important to know the units for them and how to apply them. Okay. So that's the first bit. The next bit is a question that often comes up in exams as well, required practical for density. Okay. So here we're looking at what equipment we need. So we always need to talk about equipment, method, and then how we get our results that we want. So in this case, we want to find the density of, I'm going to go with an irregularly shaped object. Okay. Actually, we'll do both. We'll show regular first, but irregular is the more difficult one. A regular shaped object, let's say like a cube. Yeah. We can measure the length of each of the sides of the cube using a ruler. Yeah. So I mentioned the equipment and what I'm doing with it, measuring the length of each of the sides, and then use that, multiply them to calculate the volume. Yeah. So here I've said measure the length, width, and height, and then multiply to calculate the volume. So we have volume. Remember the equation? Density equals mass over volume. So we've covered the volume section. We then measure the mass of the object using a mass balance. Yeah, so mass balance, put the object on there and then record the mass that you read on the scale. So that gives you the mass in kilograms. We have both of those. Then we just sub it into the equation. Mass over volume gives you density. Yeah, so that is a very straightforward way of using it for a regularly shaped object. Okay. Now the one that's more difficult and often comes with more marks, and you want to pay attention here, maybe not, is for the equation for not the equation, the experiment for an irregularly shaped object. Okay, so here you can't just measure the lengths of the sides with a ruler. You can't do that because let's say it's like a rock, for example. That's not a uniform shape, right? So you can't do that. You can't measure all the sides and find the volume. It's very irregular. So the first thing you do is find the mass of the object. So that's the same. Find the mass using the mass balance. Put it on the scale, measure the mass. Okay. Then we use a new piece of equipment here, something called a Eureka can. Okay. So I think the scientist that discovered it actually said Eureka. That's where it comes from because he found out when he was in the bathtub about the displacement of water. When he stepped in the bath, the water level rose and then it flooded out of the bathtub. This uses that concept. Okay, you fill up the Eureka can up to the spout. We then drop in our irregularly shaped object. That's going to cause this level to rise and go into the measuring cylinder. Okay. We then record that volume that comes out into the cylinder. That is our volume of the substance. Yeah, we know that because that's only going to rise and fall into the measuring cylinder once we drop the object in there. Okay. And then we have that gives us the volume. So then we have the mass, then we have the volume, and then lastly, again, we resort to the equation density equals mass over volume. Okay. So measure the mass, fill the Eureka can, measure the volume coming out the cylinder once you submerge the object, and then density equals mass over volume. Yeah, and we have a memory trick for that. If people haven't seen it before, it's been in our videos that you may have seen online. Our memory trick is Neen's beautiful face, saying me face. Yeah, so this one, M for mass. So remember to measure the mass using a mass balance. So I'll put that here. Measure mass using mass balance. And then the next one is E. So E for the Eureka can. Yeah, so E for Eureka can. So you fill and then the next one is F for fill, because we want to fill the Eureka can. So fill Eureka can to the spout. Yeah, remember we said up to the spout. Up to spout. Then A for add. Yeah, this is where we add the object into the Eureka can. So submerge it in the Eureka can. So add object to Eureka can. We then said C here, we faced for cylinder, because in the diagram earlier we mentioned the measuring cylinder. Yes, I go over here, this measuring cylinder, that's for C. So we say record volume displaced using the measuring cylinder. And lastly, we have the E, which is for the equation. Yeah, and we said the equation is density equals a mass divided by volume. Okay, so that's what I'm going to put here, equation as the last one. And the equation that we referred to, again, it's in your formula sheet, so you don't have to panic about remembering it. But I'm sure once you practice it enough, you will use it density equals mass over volume. And that is me face, the steps to remember this process, finding the density of an irregularly shaped object. You can't find many memory tricks on the notes yet. So it's all in a couple of places. You can find it on our social media. So you'll see it on TikTok, on YouTube. You'll see some of the memory tricks we posted there. And then also we go through them in our classes. If you join us on FRO classes, those are the two places you'll find it. Correct. I see some chat going on about revising effectively. Let's see Frozen's response. Decent amount every day. Take advantage of weekends and holidays. That is exactly right. So what a quote. What a quote from Frozen. Don't focus on the failure. Focus on the progression. That is a great quote. I might add that to my daily life. What a quote. That is inspirational. But correct. Yeah, if you're going to make mistakes along the way, that is part of the learning. Yeah, you don't learn anything by getting everything right. You always learn better from your mistakes. So don't be afraid to make a mistake, which is why even in this chat, if you're answering and you get something wrong, do not be embarrassed. Do not be afraid. Yeah, just be brave and understand if you make a mistake, that's fine. You're going to remember it next time, right? You're going to go, oh, I remember the time I got that wrong. You're not going to always go, I remember the time I got that right. But you'll always remember the time you got it wrong and learn from it. Yeah. W Frozen, I completely agree. What a quote. What a quote. I'm going to remember that for a long time. But okay, so that's the next bit. Yeah, we've covered that. And I want to show the guys that are new to this. If you have completed a topic, you can see here, I'll click mark as complete. Give it a second. That's going to tick. And then it should highlight this in green as complete. Yeah, so if I tick that, sorry, I probably didn't press it actually. There we go. I pressed it. It's spinning. There you go. It's ticked as complete. And you can see at the top of each topic, there is a progress bar. That is here at topic 3 and at the main level. You can see it's slightly green because I've just completed one of the topics and it ticks it here. So I know when I leave the website and come back, this is what I've covered. This is what I'm yet to cover. We covered density already, so I should really tick that off today. We've done that. Let's clear that off. There you go. That's complete. The bar should go up. See, the bar's gone up again. Yeah. And we're going to carry on because the next one is states of matter. Okay. So here we have the 3 states of matter that we see this in: solids, liquids, and gases. And here we compare their properties. Okay. Density being the highest in solids. You can see that because there are so many particles close together. Gases being the least dense because their particles are more spread out. Okay. And then in terms of their shape, so because the particles are close together, it's very rigid. It doesn't really change shape in a solid. Whereas on the flip side, a gas, it's very free in its motion, the particles, so it doesn't have a definite shape. And liquid is somewhere in between the both. It can take the shape of any container it sits in. So like a water bottle, and you put water in it, and then you move it to a glass, the water takes the shape of the glass, doesn't it? So that's where it's kind of fluid. Forgive the use of the word, but that is what it is, right? It's quite fluid. It changes its shape depending on what container it's in. Cool. So that is some of the different properties there and their density differences. And then we look at the changes in state when you go from one state to the next. Okay. So think about the perfect example to remember this for is water. Okay. So when water's solid, it's ice. Ice turning into water, it melts. That's melting. That's covered here. Yeah. The melting point of water. Can anyone tell me in the chat? Does anyone know what it is? What do we consider the melting point of water as a temperature to be? Let's see, about how to win the prize, about trying to show your hard work. That's true. I mean, it's more for yourself as well. This is just a bit of fun as well at the same time, right? It's a way to revise, but just a bit of fun. We just want to make it engaging for people. But like you said, the be all and end all isn't winning the prize. It's about the learning you get from it and obviously progressing from there. And that's what we want to do. Some people have said 100. Some people have said 0. Maybe people didn't hear the question I asked. The melting point, okay? That's from solid to liquid. Ice melts at 0 degrees Celsius, okay? So it's 0. 100 degrees is for the next state when we go from liquid to gas. The boiling point, the point at which it starts to turn into a vapor or evaporate or boil, that is 100 degrees Celsius. That is where people mentioned it. Yes, that's the difference. But yeah, good. And then the key one here is an unusual one, is where you go straight from solid to gas. See, I've drawn this arrow on the diagram here, going straight from a solid to gas. And this is what we call sublimation or subliming, okay? Because an example of where you see this is usually, probably not many of us have seen it in real life, but definitely seen it on TV, is icebergs and like ice caps in the North Pole. When you look close at it, on the surface, it's like it's smoking out of it because immediately from the surface of the ice cap is going from solid straight to vapor. And that's subliming. Yeah, there's no water dripping in between. Some of it is going straight from solid to vapor. So that is subliming. Okay, so that is states of matter. I tick that. That should complete my first section. Let's see where we are. Yes, yes. See, so that full thing now goes green. It's a great way to just track what you've covered and what you haven't. Obviously, I've done that in a whistle stop tour. You can try the questions and stuff in the tab, on the tabs, and look at the flashcards, etc. as we go. But I want to cover the content before the quiz. Speaking of which, how many people have we got? We have got 9. Not very many. There are 20 people in the chat. I was hoping to see all 20 people here. The code, I've put it here as well, is 1794330. 1794330. Who's getting a telling off? Who's getting a telling off? Correct. Correct. Who's after personal info? No one wants personal info here. See all 20 people here. There's only 10 that was Malika. Frozen was here. Debashri was someone else as well. I can't see them either. So you guys have dropped off. Come on, guys. We want a bigger. You want to? There you go. Flying Jellyfish. There you go. I think I remember that as being Debashri. So that's them back. But yeah, let's get everyone back into it. Live's a bit laggy. Sorry if it is. Smooth mute. That's 27 people in the chat, guys. That's great. If you can, anyone else you know to join, get them to join the quiz as well. We've got 12 people, but 27 in the chat. Okay, let's get the number up in the quiz before we make a start. I'm going to start in about 8 minutes. Apologies for the lag. When it gets to the quiz, always follow it directly from Kahoot, not from me, because of that lag. I don't want you to fall too far behind. It's frozen. Hey. Okay, cool. I'm going to leave that parked. 14 people. I want to see it get up to 27 by the time we start in 8 minutes. But let me go back to the notes here. So we've gone through the particle model and we've gone through states of matter. We've got this next topic to look at as well, okay, which is covering these 3 points. Internal energy, specific latent heat, and then heating and cooling graphs. So I want to cover this in the last few minutes before we start the quiz. Okay, so this is all going to come in here. What is the code? The code, Royal Akbar, you can see. Oh, hi, by the way. I haven't seen you. It's here on this side. It is 1794330. Yeah, this one here, 1794330. The code is private. Personal info. That isn't personal info. That is public info. So 1794330. Debashri, thank you for putting it in the chat. It is here, and I will flick back to it in a second. Thank you very much. So what is internal energy? So internal energy in a substance is the sum of the kinetic and the potential energies in that substance. Okay, all particles within that substance have kinetic and potential energies. Yeah, so kinetic energy with the vibration and movement of particles, and then potential energy, or gravitational potential energy sometimes called, is the position of the particles. Okay, so those two together make up the internal energy of the substance. And now that can change depending on what happens to the substance physically. And this is where we talk about heating and cooling, for example. Okay, so here we're seeing here, when you change state from solid to liquid to gas, the highest internal energy is gas and the lowest is a solid. Now let's break that down. Why is that? In a solid, we said the particles are very rigid. They can't move very much. Yeah, they vibrate in a fixed position. They can't move very much. Their kinetic energy is low. Yeah, their positions also don't change very much. They're very fixed, so their positional potential energy is low. So overall internal energy is low. One thing to notice is when you heat up a substance like a solid, eventually you reach the melting point. It's turning into a liquid. Okay, at this point, one thing happens. When you change state, the potential energy of the substance increases. Okay, but the kinetic energy doesn't. If it is blurry, hopefully it comes back to you. If not, then refresh it for your. It could be your side. If it's my side, apologies. Hopefully it will come back. A couple of you are saying it's laggy. Bear with me. I will talk a bit slowly for the next few minutes. I've got still a few minutes before the quiz starts, and we'll see. So, sorry, let me get back to the point here. So when you change the state of a substance, its potential energy increases. Okay, because the position of the particles change. What you're doing there is you're breaking down the bonds in the solid to turn it into a liquid, for example. Okay, now once it's a liquid and you're heating it up, that is going to change the kinetic energy of the particles. Okay, because in the liquid state, the particles are going to start vibrating more. They're gaining more energy. They vibrate. Their kinetic energy is going to increase. Okay, so when the temperature rises, kinetic energy increases. When the state changes, the potential energy increases. That's when you're heating. Okay, and you're heating something. So that's one thing to remember. What are the boiling and melting and freezing points for this? So this is, again, I'm referring to water as the same example. Okay, so the melting / freezing point is 0 degrees C, and the boiling or condensing point is 100 degrees C for water. Yeah, I'm only using water as an example here. Others you don't need to really remember. They will tell you in exams, in the questions, what those points are. So for this, you don't need to know that. Okay, all you need to know is the energy changes I'm referring to here. Potential and kinetic make up internal energy. As you heat something up, its internal energy increases from solid to liquid to gas. And that's because as you heat something, its temperature rises, kinetic energy increases. As you change the state, the potential energy increases. So I'm going to put that here. Increase. Well, I'm just going to put an arrow. So rising temperature means rising kinetic energy, or EK. Okay, and then changing state means that the potential energy, or EP, is increasing. Okay, that's the key thing to note there. Energy is, and you can see here, it talks about briefly a topic we've seen before. Based on a substance mass, its specific heat capacity. So I've even mentioned here, see previous notes. There are previous notes on it. Second, what are the two? Specific heat and specific latent heat. Yeah, we're comparing those two things. That's what we're going to see next. Okay, so I've ticked that. Let's look at specific latent heat. So we've got that definition of internal energy, and we're seeing how that's applied here. Specific latent heat. What is that? That is the energy required to change the state of 1 kilogram of a substance from one state to another. Okay, so the energy required to change the state of 1 kilogram of a substance. That's what specific latent heat is. And for specific heat capacity, hopefully people remember in the chat, specific heat capacity is the energy required to change the temperature of 1 kilogram of a substance by 1 degree C. Yeah. What are people saying in the chat? Hopefully the connections come back for people. Yeah, Philip's all good. Why is it blurry for everyone? It could be, some people are saying the connection is good. So it's very blurry. Apologies if it's blurry. Hopefully it comes back to you. It might be connection on our end. But if not, give it a refresh on your side. But it could be my connection. If so, I'm sorry. Hopefully it comes back. But we'll be going to the quiz soon, so then you'll follow on Kahoot and you can just hear me in the background. Yeah, you can hear me. Okay, as long as you can hear me, most importantly, it's fine. So you know that I'm not lagging behind explaining. I haven't written very much, but I'll zoom in a little bit so you can see what I've written. Again, obviously, all of this stuff I'm showing on this screen is on the site, so you can always see that on flashrevisionlab.com. Okay, specific latent heat. So I said it's energy required to change 1 kilogram of a substance, but there are two types of specific latent heat. Okay, and that depends on the state change. So specific latent heat of fusion refers to solid to liquid or liquid to solid. Yeah, so when the state changes between those two, you look at specific latent heat of fusion. And then for vaporization, as the name suggests, vaporizing from liquid to vapor or liquid to gas. Okay, so I'm just going to put that here. Specific latent heat, so latent heat is given by the letter capital L. And if I put an F for latent heat of fusion, that's solid to liquid. And if latent heat of vaporization, so with the subscript V, that is liquid to gas. Those are the state changes you're considering. Okay, so then I've got an example here. You can refer to Cambiano calculation. That's for, and then here, the last bit I want to mention is that difference, the difference between specific heat capacity and specific latent heat. Okay, so specific heat capacity, like I said, is the energy required to change the temperature of a substance, whereas specific latent heat is the energy required to change the state of a substance. Yeah, and this is the difference we're seeing here. Specific heat capacity, changing the temperature. So kinetic energy change. Remember we saw earlier about internal energy? Kinetic energy change. Then specific latent heat is change of state, energy required to change the state. So that's a potential energy change. Okay, you're breaking the bonds down to heat it out. Okay, so that is specific latent heat. And now the last bit, before I get into the quiz, is the last bit of this. So please pay attention. Let me show you here, heating and cooling graphs. Okay, so now depending on the substance, again, I'm going to refer to water as the example. I'll go through the energy part. I'll come back to that just before we start the quiz. Okay, no problem. I'll remember that. But here I'm just going to refer to heating and cooling graphs quickly. So, for example, let's say this graph at the bottom, I'm starting at 0. Or at the lowest temperature, let's say this is a solid. So let's say it's ice. Okay, I'm heating up the ice. The temperature is changing. Okay, that is where I come back to my notes on the left hand side here, and I say that changing in temperature, the kinetic energy of the particles are increasing. Yeah, so the internal rising. Then we reach the melting point, and you can hear one thing to note that's very important is that when you change state, the temperature doesn't change anymore, because before the energy was being used to increase the temperature, specific heat capacity. Now, for melting, the energy is being used to change the state of the substance. Yeah, so this is whoever. Initially, you're changing the temperature of the substance. The energy is being used for that. Then, when you get to the change of state, then you're using that energy to change the state, and therefore, no energy is being used to change the temperature. So, when you are changing state, okay. So here we're going solid, melting, melting, melting. It turns into a liquid. We're now in liquid form. Now the energy is being used to change the temperature again. The kinetic energy of the liquid is rising. Okay. And eventually, we then reach the point where it's going to start to vaporize, or we get boiling. So the energy being used to boil the substance is changing the state. So again, temperature doesn't change. Okay. And then you eventually get all vapor, and then the energy is being used to increase the temperature or kinetic energy of the gas. Okay. So that is how it works for heating. Cooling is the same, but in reverse. So you can see here, we start from the top and we start from a gas. Okay. So here we're cooling the gas. The kinetic energy of the substance is dropping. Yeah. And therefore, the internal energy is decreasing. It then starts to condense. And here, the energy is not being used to lower the temperature anymore, right? Here, we can see the energy is being used to change the state. Here, bonds are being formed between the gas molecules to turn it into a liquid. So then we get to here, the liquid then cools, its kinetic energy source is decreasing, and then we get eventually to the point where it's cold enough to start freezing. So then the energy is being used to change the state again. No temperature change at a change of state. Yeah. And then we go down again into a solid. Okay. So when every time there's a gradient in the graph, kinetic energy is changing. Anytime it's a flat line, you're changing state, the potential energy is changing. Yeah. And remember, a gas has the highest internal energy, and a solid has the lowest internal energy. Okay. And that's the comparison between the two. And someone has said the lag has gone. That is an excellent time, because we've now reached everything I wanted to cover, and we're going to get into the quiz. Yeah. Does anyone have any more questions before I make a start on the quiz? Anything on the website? Anything on our different courses we offer? FRL classes? And FRL Pro? Anything? Anyone have any questions? Your smooth newt frozen. I remember. I'm going back to here. Good luck, everybody. I only see 14 people, so I'm going to give it another minute. Who wants to jump in before I make a start? A chance to win a prize here. You've got a 1 in 7 chance at the moment of winning our 2 prizes. Yeah. So Whimsical Cat has joined. I know people want to get it cracking, but I've got to wait for some more people. I want to give it more of a chance. Who's going to join? If not, we're going to be with 15. 15 is the top. Can I get a 16? I feel like I'm at an auction here. Can I get a 16? Yes, I can get a 16. There we go. We have an auction. Cool. All right. I don't think we're going to get many more. I think we're going to end on 16 here, which means there's a 1 in 8 chance of a prize, guys. 1 in 8. That is not bad at all. Not bad at all. Okay. Cool. If we're ready to go, I can see 17 in the chat now. Are we going to start? Remember, everyone, for what you've been participating so far, not the bits where you haven't been paying attention, the bits where you've been answering my questions, please take a screenshot of the chat, of you in the chat, because if you win this prize, that's what you're going to need. Okay. So I'm going to come back here to the rules. Remember, send us 2 screenshots, you in the chat participating with me, and then 1 with you winning on the podium with your 1st or 2nd place. Okay. Let's go then. I think a lot of calls for going into it. I'm going to get into it now. Good luck, everybody. But first, I'm going to start with a poll. So let's have it. Density and states of matter. Okay. But first of all, I wanted to run by just to see how people feel about different topics in physics. Okay. What is your favorite topic in physics? Click on the one that you say is your favorite. Someone dropped an answer very quickly there. What is your favorite topic? I'll wait to tell you mine. Let's see what everyone else says. None. That's horrible. That is horrible. Can't be none. You're gonna have one favorite somewhere. I know some people don't like physics very much. It gets a lot of hate. But there we are. Electricity, someone said. Magnetism is so peak. Yeah, I hear that. I hear a lot of people say that magnetism is difficult. You're failing, but that's okay. There's time to change that. Very mixed bag, actually. So people have said electricity and waves, but the leader is energy. Okay. Mostly because it's the first topic, I guess. It's probably the easiest, I guess, as well. So I hear that. But I like forces of motion, which I thought more people would say. A lot more calculation. I like maths. So forces of motion, particularly my favorite. But yeah, quite a spread. And some people said magnetism. Fair enough. Some people do like it. Okay, cool. Then let's have a look. We're going to have our first question. Hopefully you're all ready. Make sure you're keeping an eye on your Kahoot. If you're slightly behind on the YouTube channel, then you might pay the price for it. Okay. So let's make a start. Yeah, forces is also good, and energy. Yeah, people do like those topics. And then as you get towards the end, electricity, waves, magnetism, the percentage drops. Anyway, okay. Without further ado, question one. There are 14 questions, I want to say. But question one, here we go. Quiz question to start with. What is the standard unit for density? Is it meters per second, newtons per meter squared, grams per liter, or kilograms per meter cubed? 13 answers have already dropped. 14. We're almost at the end already. People have answered that pretty quickly. I hope you got this right. I did mention this near the beginning. Remember, if you were paying attention here, you would know the answers. Remember, it's not too late to join either. If you've just joined us on the chat and you're like, oh no, I've missed this, you're only one question behind. Someone gets something wrong, you can be right back in it. So don't rule yourselves out from question one. One person got it wrong. Who said meters per second? Meters per second is for speed. Okay. I hope that person wasn't here at the beginning and missed it, because we clearly said density is mass over volume, which is kilograms per meter cubed. Okay. One thing to watch out for. Okay. How does that leave our leaderboard? So it's all tight at the top. No one got 1,000. No bots in the chat. That's good to know. We've got Magnetic Hen, Flying Jellyfish. I think that's Debauchery. It's just 10 points behind. Determined Griffin, just 1 point behind that. Vivid Mink and Giving Magpie, just 2 points between them. All very close. 30 points between the top 10. That's like a second maybe between people answering. Very, very close. Malika 7th. Frozen, I don't see you. You're the Newt, I think, if I remember right. And Daring Lion, someone said they were there. They're not there. The only one I can see I can remember is Flying Jellyfish. But who is Determined Griffin? Who's Magnetic Hen? Let me know in the chat. Let's go on to the next question. Okay. Slider. Yeah, early doors. Remember, put your slide in the right place and click submit. What is the melting point of water? Okay. Move your slider to correct position and press submit. I can see a few people have dropped it. Be careful where you do. Don't fall into a trap. Okay, I'll mention the trap shortly. I don't want to catch it. I want to see if people have noticed it or not. A couple more people left to answer. You don't know, Malika. Of course you know what it is. I'm sure you know what it is. Where is it going to fall? A lot of people have put it 0 degrees Celsius. Yeah, it wasn't in the middle. So I didn't put it in the middle on purpose to make it imbalanced. Make sure you slide over to the correct point. It's 0 degrees Celsius is the melting point for water. Yeah, it's the point at which melting starts to take place, that transition from solid to liquid for water. Okay, so I think a couple of people made a mistake on that, but where does that leave us? Yeah, a lot of movement in the board. Determined Griffin has risen. Magnetic Hen has dropped. Flying Jellyfish is still second, only 3 points behind now. And we have a few people on the podium. So nice. Okay, Frozen, you're 6th right now. That is a good place to be. Stay under the radar, but you're still in with a chance because it's very close at the top. There's only 40 points, not even 40 points between the top 5. So I'm sure you're not far behind. Snowy Leopard has climbed 4 places. Nice. I don't see you here, but you must be making a nice climb up to the top. Let's see how you get on with the next question. Okay. Let's have a look. Back to a quiz question. Which state of matter has a fixed shape? Is it solid, plasma, liquid, or gas? Wow, the answers flew in there. Hoping that not just because we covered it today, that you just know this, which one has a fixed shape. I think we're waiting for one more answer. We'll give it a few more seconds. Solid, liquid, gas, or plasma. So it's remember, tightly fixed. So the particles are close together. Everyone got it right. Fantastic. Good. If nothing, there's an answer that everyone got right. I can sleep happy. Yeah, 16 of you, all of you put solid. It's a fixed shape. Remember, particles don't move very much. They're very rigid in its structure and they vibrate in fixed positions. That's solid. So how does that change things? I think it might be pretty similar. Someone dropped. Snowy Leopard has risen again. Snowy Leopard's making a nice charge to compete. It's now 50 points between the top 5, just 51, I think. So it's all to play for. Flying Jellyfish and Determined Griffin, just 1 point. I just noticed that it is tight. I think we had a similar thing on Neen's last live, so it's going to be very, very close. Who's going to slip? Who's going to be quicker? Let's find out from the next question. Let's see. Quiz question again. What state change occurs during melting? What state change? Is it liquid to gas, liquid to solid, solid to liquid, or gas to liquid? Be careful. Think about the question I've asked you there. What state change occurs during melting? 13 points off top 5 Frozen. You're close. Let's see whether you get there for this. 5 seconds left. What have people put? Hopefully they've put the right answer. The right answer is solid to liquid. One person put liquid to solid. I said to be careful because melting. So think of ice melting. It's solid to liquid. Ice melts, right? Ice is solid. So it's solid to liquid. Okay. Let's see. Did that change any of the top 5? Someone dropped out. I don't know who it was, but I saw someone fly off. Was that you, Debashri? Was it you? I don't know because you're not there anymore. Smooth Newt. There you are, Frozen in the top 3. Giving it a good fight. Nice. You're back on the podium. Get in there. Philip, where are you? Are you there at the top? Are you Determined Griffin? You always keep it silent till the end. Is that going to be you? Playful Yeti in second. It's still close there between those two. And yeah, all to play for, guys. You're second. Nice. Nice. Philip, Sammy, if you're new here, Philip will not tell you, okay? Philip is a man of mystery. We'll find out at the end. So I've given up on asking him. So we'll find out at the end. Philip, Frozen, exactly. You've got to lock in. Let's get into the next one. Let's see it. True or false this time? Temperature stays constant during state change. Is that true or false? Quick answers. I hope so, because I did mention it several times as I got towards the end there. I was very conscious to mention it. It's a very important point. You do need to know it. Is it the same during state change? So Sammy's given an answer in the chat. Is he giving the true answer or is he not? Let's see. True. It's a split. People have split on that. That is, honestly, I'm surprised. I mentioned it several times. So many times I talked about, on the flat graph, when we saw the heating and cooling graphs, I said every time it's flat, when you're changing state, the temperature isn't changing. Temperature stays the same during a state change, okay? So guys, if there's nothing you take away from today, it's that, okay? Take that away from today. That when you have a state change, there is no change in temperature. The temperature stays constant because the energy is being used to change the state. That's what I kept saying for those of you that were here. So I can see 8 of you did really listen to me. So appreciate you guys. 8 of you may have missed it. So one thing to take from today, okay? Let's see how that plays on the leaderboard. There are 14 questions in total, are correct. 5 people are on a 4-question answer streak. Determined Griffin has taken a bit more of a gap on to Playful Yeti. That gap is now 33, but still close. Smooth Newt, Philip, you're in with a chance on that second place, if not the first as well. So stay in there. Like you said, lock in. You can get it. Let's see how the next question changes things. Let's go. Quiz question again. Which energy store increases when boiling a substance? Again, I mentioned this, okay? I mentioned this, so hopefully you listened to me. Hopefully you did. And you would know the right one. Is it kinetic energy, rest mass, electrical energy, or potential energy? Which energy store is it when you change the state? Remember, it's boiling, so the state is changing. So which one is it? One more second. Let's see what people put. We have the wrong answer. Only one person got it right. Only one person, guys. I'm surprised. I'm very, very surprised. I don't know what happened there. That is, oh, I'm shocked. I'm lost for words. Guys, I was saying when you increase the temperature of a substance, the particles gain more energy and vibrate more. They gain kinetic energy when the temperature is rising, not when you're boiling. Boiling is when you're changing the state. When you change the state of a substance, that is when the potential energy increases. Yeah, I did mention this. You forgot. That's a shame. Sorry, but that is one thing to take again then. Yeah, this is exactly why we're doing this. Yeah, at the same time as I'm surprised and slightly disappointed, I can't lie that people got this wrong. But it's a point of learning, yeah, and it's exactly why we do this. Remember I said earlier, you learn from your mistakes. This is one of them. Potential energy changes when you change a state. Kinetic energy changes when the temperature changes, okay? That's the key thing to take away. I did have it in my notes on the side here. I put it here, didn't I? Here, in red. Yeah, I circled it in red as well, yeah? Increasing in temperature increases kinetic energy. Changing state underneath there increases the potential energy, okay? Who got it right? Whoever they are, they're probably at the top, so let's see. Yeah, they are. It's Magnetic Hen. Whoever that was, Magnetic Hen got it. And look at the gap. Look at the gap. It's almost 800 points. More than 800. 865 points, that is. Yeah. But all to play for, because if they make a mistake, everyone comes back in. It's exactly how this game works. But that was a combo breaker. I am still stunned that only one person got it right. I thought only one person got it wrong to start with. One got it right. Wow. Not seen that in a long time. Philip is Griffin confirmed. We'll see. We'll see. We'll see. Still on the podium. Yeah, he's giving some clues away. It might be him, but let's see. Cool. All right. Everyone regroup. Everyone lock in. We're getting back into it. Everyone get this one right this time, okay? Let's see. What is the question? It's a quiz question again. What is the equation for calculating specific latent heat? I mentioned it again. Is it E equals mc delta T? Is it P equals W over T? Is it E equals ML? Or is it F equals MA? We saw it. We saw it there. Which one is it going to be? 13 answers. 5 more seconds. Should be about 3 more people left to answer. You got it wrong. Are you sure? Remember, getting it quickly is one thing, but getting it right is another. And I thought this was the mistake people were going to make. It's the second thing I covered. I covered this again, guys. And specific heat capacity is the energy required to change the temperature. Hence, in this equation, delta T, change in temperature. That is for specific heat capacity. Okay. Energy required to change the state. That is specific latent heat. And I even mentioned it here in the notes. You can see it here. LF and LH, latent heat of fusion, for changing the state of solid to liquid, and latent heat of vaporization. It has the letter L. That was the key clue there. Latent heat beginning with L. Yeah, so that was the clue. So how does that change the leaderboard? Let's have a look. So determined Griffin and Magnetic Hen still having their own battle. It's all changed though, third and fourth. They climbed up from beneath fifth. So that's Blissful Mantis and Snowy Leopard. Who's that in the chat? Drop it down. I'm so bad. You're not bad. You're not bad. I don't know if it's people are having a bad day, because a lot of people have got it wrong. But hopefully this is a point of learning. Yeah, guys. That's what this is for. Obviously, I say I'm disappointed, but ultimately I want you to learn from it. So I'm telling you what the answer is now. Hopefully you learn that from going forward. You remember the mistake you made in the quiz. That's a learning point for you to remember going forwards. Okay. So don't get too disheartened. Keep pushing on to the rest of these questions. There aren't many left. I'll be honest, I don't know how many are left. I've lost how many we are through the shock of it all. But let's go to the next one. Quiz again. What state change occurs in sublimation? Again, I mentioned this, guys. I did mention this, right? So hopefully you get it. Is it solid to gas, solid to liquid, gas to solid, or liquid to gas? Which one is it, guys? 15 answers. Only a couple more left to answer. Pretty quick there. So it's going to be about time. Or is it? I don't know anymore. I've seen people make mistakes. Has anyone made a mistake again? It has happened again. Less so, but it has happened again. Solid to gas. Remember I said on the glacier or an ice cap, you see the smoke coming off the ice cap because it's going straight from solid to gas. That is subliming. I showed you in the graph as well. The arrow went straight from solid to gas. Yeah. So I think a lot of fumbling. You're right. A lot of fumbling. Your screen is frozen. That is a disaster. I'm sorry if that's the case. I don't know if that's on your side. Has anyone else's screen frozen? Hopefully not. No one else has said that. Hopefully you come back. Did you manage to answer that question, Frozen? I was going to say maybe to do with your name. I didn't want to say it too soon, but Philip has dropped that. Everyone else has said their screen is normal, but okay. Could be big change here. People have got that wrong. Yeah, people have said gas to solid. That isn't sublimation. It's the other way. Liquid to gas. That's vaporization, evaporation, isn't it? Boiling. You did with 2 seconds left. Okay, that's a shame. That's annoying for you, but hopefully you come back into it. Determined Griffin is back at the top, and there's 110 points in it. So that's quite a swing. I thought you were quite far behind, Philip. So you've gone and taken the lead. Let's see how it goes for the rest of it. I think we've had about, I think 9 questions have been completed. So we have about 5 left. Okay. We're in the final 5. Let's see what the next one is. Yeah, we're on question 10 of 15. So 6 left. The energy required to change the state of 1 kilogram of substance from solid to liquid is known as what? Specific latent heat of melting, specific heat capacity, specific latent heat of fusion, or specific latent heat of vaporization. Answers came in quick. And again, we've had a mix. Again. People have fallen for the trap. It's not specific latent heat of melting. That is not a term, right? Again, I've actually even left the notes open here to help. Yeah, I made the short form F and V. F for fusion is solid to liquid. Yeah. Solid to liquid. So the answer is specific latent heat of fusion, which is the third one. Only 5 people got it right. I'm surprised. This has probably thrown everyone all over the place. Debashri, you've got it now. Nice. Let's see. Have a look. Melting is not. Melting is the term of a state change. Yeah. The energy required to change the state is specific latent heat of fusion. Okay. I showed it in the notes. So that is what it is. It's not melting. Okay. Melting is the process of converting a solid into a liquid. But the energy required to change, look at the question, right? The energy required to change the state of 1 kilogram of a substance from solid to liquid is called specific latent heat of fusion. Okay. It's the energy required to melt it, basically. Okay, how does that change the leaderboard? Wow, wow, everyone's everywhere. I don't even know who's who anymore. Snowy Leopard, I swear this is the second time you've had some sort of dramatic rise. A rise and fall and a rise again. Nice. Playful Yeti has gone up into 4th. Determined Griffin, you're in 3rd. Philip, I think that's you. You're in with a chance, but you're slipping away. Can you bring it back? But Magnetic Hen has risen up again to the top with 7726. There's a bit of a gap now, but that can change. Yeah, exactly. See, there, someone said I did it quickly, then you get it wrong. So it's that balance. You take a little bit longer, but you get the answer right. It's going to serve you better, isn't it? So it's that balance. You're new to this. How often does this happen? So we do this every Sunday evening, 7:45, and every Wednesday evening, 8:30. Okay. And on Sunday, it's physics. On Wednesday, it changes between biology and chemistry, hosted by Neen. Yeah. So join us for that. If you want to join our lessons, it's FRL classes. Check out our website, flashrevisionlab.com, for some more on that. But we are going to move on to the next one. Aptly so, as Uber has said. So I'm going to move on. What state change is taking place in the point indicated by the arrow? So you're not going to see it straight away. It's going to appear where the arrow is pointing. What is showing there? So it's an arrow. You can see the arrow now, but what is it? Remember, this looks like the graph is rising. This is a heating graph. The temperature is rising. What is that arrow showing? Who knows the answer? A few people have typed. There should be a few different options here. Just to make sure I've covered everything. Hopefully I've covered all the answers that you can, which is this. You can see there, it's at the end. So if you've heated, it's changing state there. Wow, loads of different answers. Loads. The correct answers are boiling. 6 people put boiling. Yeah, the other ones I would have given are evaporating, vaporizing, or evaporation. Yeah, those are all other options I would give you. Some people put like freezing and stuff. No, because we're heating and we're at the high end. So we're at the last state change, which is liquid to gas. Okay, so freezing would have been on a cooling graph down at the bottom, because you're going from liquid to solid. Yeah, so you got that the wrong way around. Some other ones, someone put no change. There is a change. There's no change in temperature, but there is a change in state, which is what I was asking. What state change? Okay, let's have a look. How does that change things? Magnetic Hen, Snowy Leopard. The top 3 have stayed the same. They got it right. And there we go. Frozen is back up 4th place. Oh, I've just seen your message in the chat. Nicely done. Nicely done. You're back in it. You're back in it. It's not over yet. There's about another 3 questions to go. So all to play for. We've seen the shock horror that I had on my face earlier with everyone getting a question wrong. How often does this competition sessions happen? So I mentioned this earlier. Sorry. This happens every Sunday and every Wednesday. Sunday at 7:45 and Wednesday at 8:30. Okay. Wednesdays will be biology and chemistry, and Sundays will be physics with me. Okay. Wednesdays are with Neen. So look forward to seeing you there. We're going to be moving between TikTok and YouTube. Today we're on YouTube, but we will be moving to TikTok just to see how that does with people as well. Philip, we need more multi-selects for higher chance of moving. Yeah. We're not there yet. We're not at the end. So there may be multi-selects. There may be some other options. This was one of them, right? The typing. That was a different one. So I wanted to see if it catches people out or not. But let's have a look at the next question. Good luck. Question 12. 3 more to go. Which state of matter is the least dense? Solid, liquid, gas, or plasma? Again, I mentioned this, right? I talked about the changes in states. I talked about what they are, the 3 states of matter are, and everyone bar one got it right. I never mentioned plasma today. So whoever said that was either not in the lesson or not listening, because I didn't mention plasma at all in the class. It is gas. Gas is the least dense, right? Because the particles it's about how condensed or pushed together the particles are. Gases, they can be more spread out, move very freely. Solid is very compact. They're the most dense. Then liquid is in the halfway house between the two. Gas is the least dense state of matter. Yeah. You need everyone to get it wrong. That is what you bank on when you're in that position. You never know. It could have been first place that put plasma, but I hope not. They did it. It isn't. It's unchanged, but the gaps are kind of creeping closer. Just over 300 between Snowy Leopard and Magnetic Hen. That is not a lot. That is just answering a question slower. Even between Determined Griffin and Snowy Leopard, there is a chance. Smooth Newt Frozen, You're there and thereabouts, but you need a bit more. You're almost there. You're almost there. Guys, just also as a quick mention, if you can, please, can you like the YouTube video and hype it as well, because it just gives us a bit more exposure, get more people in on this, and a chance to win even better prizes. Yeah, we're giving £25 Amazon vouchers, but we want to increase that. The only way we can do that is if we have more people involved. Can it be on YouTube, please? Yeah, it's what we're doing now, but we're going to switch it up because we want to see how things do on other platforms. Yeah, we have a big following on TikTok. We want to get more people involved. TikTok might be the way, so we just want to see how that looks as well. So, but it will be a mix. It won't mean that we're going to TikTok forever. We just want to go between the two. Okay. But here we are for now. I'm going to carry on with this. We've got a couple of questions left. Question number 13, pin answer. Okay, you wanted something different, I think, Philip. Here we go. Which diagram shows the particle arrangement for water at 120 degrees? You move your pin to the section and press submit. Okay, if you just hover over there, it doesn't finish the answer. Make sure you press submit. I'm hoping everyone got the right answer here. I'm hoping so. It's water at 120 degrees. Think about at 120 degrees, what state is water going to be in? 10K subs. Have we hit it? Oh, that's amazing. Good stuff. Oh, we were waiting for that countdown. We finally hit 10K subs. Glad to hear it. And we've got a mix. Some people have gone in the middle. Water is a liquid, but I said at 120 degrees C in the question. 120 degrees C. Remember, the boiling point is 100 degrees C. So if you're 120, you're definitely above it having been boiled. So it's turned into a vapor. We are at gas, which is on the right-hand side. You know, the gas particles are nice and far apart. So the answer is on the right. Mixed bag here. 5 wrong, 11 right. Where does that put the leaderboard? Let's see. It's all still close. It's still close at the top. About 302 points. So it's coming down again. Daring Line is back in the game with 3 in a row. Smooth Newt, Determined Griffin, our FRL classes gang, you're up there. This is where I want to see you. So surely it's helping your understanding and you're getting there. Hopefully you can get in with a chance on a prize. Hang in there. 2 more questions to go. Let's have a look at the next question. Good luck. Type answer again. You got to type. Double points for this. Okay, this could swing things. How many meters cubed are there in 1,000 centimeters cubed of water? So on this one, it's a conversion here, right? So think about your conversion from centimeters to meters, but this is centimeters cubed to meters cubed. Yeah, I've thrown one off here, so there can't be any bots in the chat that are getting it. If you're getting it, you're getting it through understanding and remembering it. Yeah, so I've thrown one in here as a different one. How do you convert from centimeters to meters? I will explain this in a second as it comes up. I'll wait for the last answers to come in and I'll put it here as to how we get there. A couple of answers left, a couple of seconds to go. Who got it right? Who got it wrong? Really varying in answers there. The answer is 0.001. Only 3 people got it right. Okay, this is the intention of this. I will show you why. Okay, 1,000 centimeters cubed. Okay, if you have 1,000 centimeters, then centimeters to meters, we need to think about how many there are. 1 meter is 100 centimeters, right? So to go from centimeters to meters, you divide by 100. However, we've got centimeters cubed. So that means you need to divide by 100 cubed. So you divide by 100, divide by 100, and divide by 100. So let's break that down. 1,000 divided by 100. I'm just going to ignore actually the units. So 1,000 divided by 100, that's going to lead you to 10. Yeah. So that's the first time we divided by 100. We need to do this 2 more times. 10 divided by 100, that leads you to 0.1. Okay. And then we need to divide it 1 more time. 0.1 divided by 100, and that gives you 0.001 meters cubed. Okay. So to go from centimeters cubed to meters cubed, you divide by 100 cubed. In other words, you divide by 1,000,000. Okay. That's what we've done there. I really want to throw that question in to throw people off because it's just a mathematical one. We see that a few times. Someone said it's wraps. You're one of the 3, Debashri. Where does that put you? Let's see how the leaderboard, the game's gone. Has it? No, Magnetic Hen and Snowy Leopard are right up with each other. No one really moved though. So if Debashri, if you got that right, I was expecting to see you climb then because I only saw those 2 get points. Maybe you must have really gone down to have climbed up. So you must be pretty close to the leaderboard. 7th. Yeah, so maybe you were low down and you've really caught up. So nice. Okay, I think we're on to the last question. Good luck, guys. Put the steps to find the density of an irregularly shaped object in the correct order. So different steps there. Make sure you drag them into the right place. Once you're happy with your order, press submit. who's going to get this right, who's going to get this wrong. Remember, I gave a breakdown of this in the notes that I wrote on this page. I broke down the memory trick for this. Remember, it's an irregularly shaped object. Think about the steps that I've mentioned here. Who's going to get this right? We've got a few more answers left to go. I've given a bit more time so you can rearrange the puzzle. I didn't want to make it a rush like the last few. Maybe top 3 Frozen, maybe not. Maybe you got second. Maybe you got second. I think first may have been out of your reach. There we go. 11 out of 12 people got that right. That is good to see. We got to the end and people know the order of this. Yeah. So first measure the mass to get the mass in kilograms. Then we said fill the Eureka can. Remember me face, F for fill, E for Eureka can. A to submerge add the object, so submerge object. That was all in the red section. Then measure the volume, so that's measuring cylinder, so that was C. And then lastly, E, the equation, calculate density using the equation density equals mass over volume, okay? And that was that. That is the end of the quiz. Where does that leave everyone? Here's the podium. Who got what? Third place with 10,528 is Determined Griffin. I think that was Philip. And in that second is Snowy Leopard with 12,964. It was very close in the end. They were running away with it initially, but Magnetic Hen just by about 100 points. So it was really close. It was really, really close. Magnetic Hen, congrats on your victory. Snowy Leopard, congrats. You got the £5 voucher. Magnetic Hen, you got the £25 voucher. Remember, guys, I'll go back to the top. If you want to send us or you want to claim your prize, make sure you send a screenshot of your character on this podium as well as your participation in the chat, and we will send you your voucher. So congratulations, guys. That is Magnetic Hen with the victory. Snowy Leopard, whoever you are, drop me a message. Make sure you have your screenshots sent. Remember, if you don't win the prize. So we'll see. If they send it, they will get it. Guys, I think it's been a pleasure. Thank you very much for your time today. Hopefully it was useful for you all. Just wanted to make this a bit of fun as we always do. And I think it does get competitive, but that's part of the joy of it. And I'm hoping today especially is one where I've seen hopefully people have learned something. Yeah, because this was a tricky one and one that caught a few people out. Okay, so I want you to take away your learning from this on the mistakes that you made. Next Sunday, please do 2 quizzes and 4 winners. We will think about it. It's just a lot of work with everything we've got on with our classes, so it's quite tricky. But we do want to grow this. Obviously, it makes more interest to us if we've got more people. Okay, this only had 16 people. This is why we're saying if you can get more people involved with us, we can make these kind of things happen. We can do quizzes more often, offer more prizes, and that's what we want to do. So this is why we may transition to TikTok, see how that goes. If we get more people, we can do these things and offer you more prizes. And yeah, thank you guys. 10K. I'm surprised. I was looking at it, looking at if it was going to hit 10K, and I've completely forgotten about it the last few days. But no, good to hear we've reached 10K. That's great. Thank you all. Thank you all for subscribing and taking part and joining us on our journey. Having you here to learn with us is what makes it worthwhile. Seeing you guys chat, seeing you ask us questions, and seeing the development of some people and the grades that they've achieved. That is what we're here for. Yeah. So thank you very much, guys. If it's going to be on TikTok, you can't make it there. 100K coming soon. I hope so. Yeah, we want to help you get your grades up. Remember, like I said, if you want to join us, flashrevisionlab.com, sign up to the website for free. You can see there we've got our FRL classes package where we're doing classes every week. Frozen, Philip, the guys on here, they are part of it already. And they are joining every week and they get a workbook every week. And they get with finished notes that we go through in the lesson. So we finish off all the notes. They get homeworks to go through, and we have videos for those homeworks that they can review. So it's just we're trying to give you as much as we can to help. So FRL Pro gives you everything on the website. FRL Classes gives you access to the lessons every week. I haven't seen you there, so take a look. If you've got FRL Pro, that's the website. Like I said, that's everything on the website. FRL Classes is what you want if you want to join our classes every week. And that is where we will do everything and give you all the workbooks to cover the syllabus entirely. For FRL classes, it's £22 a month. And that is for, like I said, 3 sciences. We do maths, biology, physics, and chemistry every week. Yeah, so chemistry on a Friday, biology and physics on a Sunday. So the guys, they can tell you here, they're on the chat now. They were here for my class. I just did it from 6:30 to 7:30, and then we jumped on here at 7:45. And that is £22 for 12 classes a month. Yeah, so that's like, what, £2 a class? Not even. Less than that. Yeah, less than £2 a class. So I mean, we can't do it for much less than that, if I'm honest. Yeah, we're giving lessons away at £2 a class. So and all of those classes, they are recorded. Yeah. So if you missed them, if you can't make those times we've said, they are recorded. So you can always go back to them and follow them later. And it's online. It's all online. Yes. Yeah. So you get access to the link. We give you the link to the class. You can join the class live, or it's recorded so you can see it later on, with all the questions and the homeworks and all of that. So please do have a look. And we'd love to have you join us. So take a look, and hopefully we'll see you soon. But otherwise, other than that, that is where we'll help you guys. So if you want to join via that. We'll see you there on the FRO website. Exactly. Yeah. So we'll see you there. Thank you very much for your time, guys. Enjoy the rest of your Sunday evenings. And for those of you on FRO classes, I'll see you next Sunday. And otherwise, I'll see you for the next live next week. Thank you very much. Cheers, guys. Take care. Thank you. Thanks, Frozen. You're aiming for a 7 and got a 5 in December. Yes, you can. You can definitely do it. Yeah, you're working hard. That's one thing. And like I said, following those steps, taking revision notes, and then using those notes, learning them, and then putting them into practice. Yeah, it's not just reading the notes and going, yeah, I get it. It's practicing it. That's important. Yeah, so make sure you do that. If you do that, like I say, iteratively. So you do it again and again and again. That's what's going to build up, one, your confidence, two, your speed, and three, just your knowledge overall. Yeah. So if you do that, that's going to get you there. Okay. Cool. Thank you, guys. I'll wait around for another few seconds for any more questions. If not, enjoy the rest of your evening, guys. Take care. Thank you very much. Yep. I see a message from me. I'll wait for you to message your message here. Is it Hearty? Sorry if I'm saying it wrong. How about for your question? You would like to know how to up your grade. This is exactly what I've just been explaining. You need some notes. You need to revise from those notes. That's what we're trying to give you. Yeah, we're trying to give you that. You get a set of notes. You then apply it to some questions, and revise. Use past paper questions as an example. Look at where you went wrong, and then revisit that. It's a cycle of repeating. Yeah, that's how you're going to do it. It's all about learning the content and then practicing it. That is the way to do it. Yeah, that is the way you're going to up your grade. Okay, you have the notes, but then now it's about using it with questions. Okay, so trying past paper questions. Like I said, we've got questions on the website. If you join our classes, we give you even more questions than that. There's past paper questions available online. So use all those resources to you and try as many questions as possible. That's where you're going to realize which notes you're not learning and which ones you are. Okay, so that's the best way to do it. Okay, I'm going to jump off now. Need to have a bit of my evening left before I go to bed. So thank you very much. Thank you. And I'll see you soon. Take care.